Hello students, today we will study high pass filter and will evaluate low cutoff frequency of high pass filter, pass band gain of high pass filter, and will plot the frequency response of high pass filter. In order to perform this experiment, we need an oscilloscope for observing various waveforms. We need a kit for high pass filter, and a function generator is needed to provide input to the high pass filter. A multimeter is also required to take measurement of resistance value of this high pass filter. So as you know that output voltage of this high pass filter is given by V0 equal to 1 plus Rf upon R1 times Vin, where Vin is the input provided to the high pass filter, and the low cutoff frequency of this high pass filter is given by F1 equal to 1 upon 2 pi Rc. So before starting the experiment, we will set this resistance value at 15.9 kilo ohms, and with this value we get 1 upon 2 pi Rc equal to 1 kilo hertz. So this will be the cutoff frequency for this high pass filter. So frequencies above this frequency will be passed through this high pass filter, and frequencies below 1 kilohertz will be attenuated by this filter. So now we will make connections. First of all, we will observe the input at the DSO. We have connected the function generator output to the channel number 1 of our DSO. Here you can observe the input waveform. We will ensure the frequency and input voltage peak to peak. At this moment we are getting 102 hertz input and 2.05 volts as peak to peak input voltage. Now we will make connections. We will give the supply voltage to this operational amplifier. Minus 12 volt terminal of this op-amp is connected with minus 12 volt power supply. Plus 12 volt terminal of this operational amplifier is connected with plus 12 volt power supply terminal. Input coming from function generator is connected here. The ground terminal is connected at TP7, and positive terminal of oscilloscope function generator is connected at V in point of this function and this high pass filter, and output is taken from the V out point and it is connected at channel number 2 of DSO. So you can observe the input and output waveform. This is your input waveform, this is your output waveform. We will record these things. The input frequency is 102 hertz, input voltage is 2.05 volts, and output voltage is 2.09 volts. In this way the gain is equal to 1.01 and dB value is equal to 0.16. Now we will repeat this thing for another frequency. We will increase the frequency. Say we will take this frequency as, suppose we are taking this as 867 hertz, and you can observe the input and output at the DSO. We will record this reading. The input frequency here is 868 hertz and input voltage is equal to 2.09 and output voltage is 4.02 volts. So gain will be equal to 1.9 and dB value will be equal to 5.68. Now we will take another reading. We will change input frequency to some higher values by rotating this frequency variable now at say around 5 kilohertz. So in this case the input and output are displayed here. You can note down the readings of input and output. At this moment we have 5.2 kilohertz, means 5264 hertz. Input is 2.33 volts and output is 5.1 volts. So gain will be 2.18 and gain in dB will be equal to 6.82. Now again we'll increase the frequency to some higher value. We'll take this as 10.11 kilohertz, means 10.116, and input peak to peak is 2.13 volts and output is 5 volts. So gain in this case will be 2.34 and gain in dB will be equal to 7.411. Now we'll change the frequency up to some higher value. Suppose we'll take this at around this 42 kilohertz. So at this point we are getting input like this and output like this. We can record this. Input is 42.83 kilohertz, so 43.830 and input peak to peak is 2.13 in this case, and output is equal to 5.1 volts peak to peak. So gain is like this. Again we can take more readings by changing the input frequency. We have taken 500 around 772. At this moment we have 765 kilohertz, 765 100, and input is 2.09 volts peak to peak and output is 4.8 volts peak to peak, and in this case we are getting 7.22 dB gain. So in this way you can observe from this characteristic obtained experimentally that it is following the similar kind of characteristic of an ideal high pass filter. So in this way we have studied the performance of a high pass filter. Now you can also perform the similar kind of activities by changing the gain of the high pass filter. In order to change the gain of the amplifier, you can change the value of R1 or you can change the value of RF. Depending upon the various set of R1 and RF values, you will get different set of gains, and in that way, by keeping the frequency as a variable, you can observe the characteristic of the high pass filter. And after all, you can plot the characteristic of high pass filter and you will get this kind of waveform. Thank you very much.